The ranking game is another how happy you are with different um, brands or types of cars, and the what probably happened. There are a number of questions on a 10-point scale. It looks like. What's the most we can be? 7? Is that the biggest number in this table? Probably it's a 7-point scale.
Oh, we need. You have 7.75.
Oh, good point. If we can get to 7.75, then it's probably maybe it's a 10-point scale for all I know. Actually, I wouldn't be surprised. 10-point scale is more common than an. Have I ever seen an 8-point scale? Probably not. Probably a 10-point scale. And they answer a number of questions about how they like different cars. And then, based on their answers, we're going to group them together. So, in this case, I need to go to my big view of this. So the different clusters are different. Evidently, the cluster 5 people don't like BMWs because the cluster 5 people have a mean of less than 3. Wow, those 5 people are weird. They don't like any of the fun cars. What do the cluster 5 people? We have the notes that come in on top of this in a second, but I'm just looking at the numbers. Going those. So what do the cluster 5 people? Oh, they like their Jeeps. So anything else? They're kind of grumpy people. American. No, they still don't like. Look. By the way, this is one of the things that comes up on the slide. Nobody likes Chrysler. You guys, Mercedes bought Chrysler at one point. That was an interesting marriage that didn't last for very long. Why is it called Porsche polarization? The clusters 2 and 3, those people like their Porsches. By the way, at least in previous days, the Europeans think it's funny that Americans like Porsches. If a European wants a nice car, they buy a Mercedes, not a Porsche. But different attitudes. There's our uniformly. I'll go through these. Uniformly unpopular Chrysler. What makes Ford better than Chrysler? I don't know. These are just, remember, these are MBAs, so they're completely loony. Who knows how they make decisions? So how are clusters 2 and 3 different? Clusters 2 and 3 are different because they both like BMWs and Porsches. That's good. But they're pretty different on the Volvo one. So, yeah. They're different. They have to be different because they're in different clusters. Remember, we're grouping together the human beings, the people, not the other way around. We're not making an overall measure of how much people like cars.
They're more different in how much they like Fords.
Wow. Need to change the slide. Heavy effort. Probably not going to happen. That's completely true, right? So group 2 likes their boxy cars. How about that? The newest trucks are all big boxes. I'm incredibly curious why they did that. They took trucks that looked like trucks and they made them into boxes that look like they're from the 50s. Is that good? I don't know. Hopefully the insides aren't like trucks from the 50s. I don't know. But it's interesting. I mean, how do they make these decisions? They think they're going to sell more cars if they make it look like that. Some MBAs made the decision. These are the same MBAs that like boxes, I guess. but their job is to design trucks. And so all the clusters, the point is all the clusters are different from each other. And they're grouping the MBAs in this case together into 5 similar groups. Now, do we really have 5 clusters? This doesn't tell us, right? How do we get to 5 clusters? Well, we'll talk about that in a bit. Do we need to talk about the variability and the R squared stuff? Not really. We'll get to it a little bit. R like in a regression problem, lots of different procedures have R squared type measures, and they are helpful in the sense that you know that R squared near 0 means nothing, and R squared near 1 means there's a lot of stuff going on. And in cluster analysis, it's how close the points are to their mean. If the points are clustered together towards the mean of their cluster, then the R squared measure is more than the, let me draw one picture because if we have this situation, let's make 3 of them. And we tell it we have 3 clusters. The R squared measure is, this is coming up on a future slide, is the within cluster sum of squares. In other words, within the cluster, what's the distance between all the points in the mean? So the within cluster sum of squares is quite small in this case, because I got the clusters right. But if I get the clusters wrong, and I say that there are 2 clusters, like this, then the mean of this cluster is in here, right? And all of a sudden, the distance is much higher between when you have 2 clusters. So that's going to make R squared small in this case, but big in so let's see. We're going to have and we also have the total variability involved. The total variability is just take your data and measure the distance between all the points in the multivariate mean. So it doesn't matter what your data looks like. It's got a mean in there. And we can measure the total distance between each point and the mean of the whole group. So that's the total variability. So it's like an ANOVA situation where you have total variability, then you have variability within the cluster. So that down here, the variability measure ends up in this thing called an F statistic. Notice there's no p-value there. It's sort of like it's an F statistic because it's the sum of squared things, and that's lovely. But the p-value part of it isn't here. Size of it tells us something if you're an expert in cluster analysis. This is the how you end up with a measure that's like R squared, based on this sum of squares idea. And there's the, yeah. Have I seen it used? Not really. It's a nice mathematical idea. And maybe it'd be helpful when I try to explain to biologists why their cluster analysis isn't useful. And say, well, look, your R squared is small. Maybe worth a try the next time. Because they do understand R squared. Oh, the output. The output will tell you how the points were grouped together. If you're doing agglomerative clustering, which is almost always happening, it will tell you how the clusters were joined together. And if you have a reasonably small data set, this can be very helpful. It's nice to know that points 4 and 7 were the closest together in the whole data set. And that's summarized in the process. If you have 20,000 points, you're never going to be able to produce, it's not going to make any sense. But if you want to know how the points are being joined together, then you can find that out. Okay, SAS code, do we care about the SAS code? Not really. Notice we're running FastClus here. FastClus, by the way, if you don't use the defaults, could be semi-useful. It is what we call a k-means procedure, and it's really the defaults that are the terrible part. Yeah. Okay. So literally the most famous cluster analysis example is called Fisher's iris data. And because it came from R.A. Fisher, that's probably why it's still the most famous example of, and why? Well, it's famous because there are two species of irises. Probably there's stories about Fisher growing them in his greenhouse or something like that, and that's lovely. And then there's two measures